In this video, I'm going to show you how to obtain data from the National Water Information Systems Mapper from the USGS. Each of these dots on the map represents a water quality monitoring station. One could simply click on the dot to obtain the data from each of the sites, or type in the information required for any one of those sites into the sidebar and obtain the data that way. For this exercise, I type in Flax Pond Marine Station, Oldfield, New York. It takes me to my station. I click on my station and access the data. There are lots of different variables and metrics that have been measured at this site, ranging from temperature, pH, and water quality, and turbidity, to salinity and conductance. What I will do for this is select the parameters that I want to test. Being that the site I'm comparing to does not have data on any of the other additional factors that are listed here at this site, I'm only going to do my data analysis on temperature, and that data analysis will be from 06 to 5. Once we click on Access Data, it will bring us to all of the data for the site that has been collected at the Oldfield site. So here you'll see a variety of different parameters that have been measured. So one doesn't need to just take temperature into consideration, but for this investigation, we're looking specifically at temperature. What I do then is click on Time Series and I hit Go. First thing is you look at a visual investigation of the data. But for what we're doing today, we're going to actually have a set of dates that we're interested in. Notice here you're looking at most recent data. So what we're going to do is we're going to view data records for a specific time span. So we are going to change the time span for the June of last year, prior to the hottest day of the year. So if we do 0625 2023 to the hottest day of the year was on record was July 3rd. So we're going to go 10 days past July 3rd to the 13th of 2023. And we are going to change that time span and first look at the visual observation of the data. What's really great about this online app is that you can actually have students investigate the changes within the temperature right on the app itself. But for what we're doing is we want to have students get a visual understanding of what to do with the data once they get it. So we are going to download the data for this time period. So to do that, we click on the Legacy Real-Time Time page. And from here, we're going to make sure that we collect the data from our time period, which is what we looked at prior, in a tab-separated format. But I don't want all of these variables for now. I just want to focus on the temperature. So I'm unclicking each one of these variables, but you'll see here that you have a variety of different factors that you could do these analyses on. So again, we're changing our dates to the June 25th start date, which is the 10 days approximately prior to the July 3rd hottest day on record, and we're going to go out to the 13th past that. And once we do that, we hit go. And what we have here now is all of the temperature data for the selected time period. And what we're going to do is we're going to use this time data, and we're also going to use this data and compare it to the data that we have on our river ecosystem. So I'm going to pause for now. In the data for the Iowa site, I'm going to type in the site number because I do know that. And what you can do here is, again, we search in the prior by the site name and location. For this, we're going to search by the site number. So I'm clicking on the site number. It brings me right to the site in Iowa. I'll show you on the scale just by zooming out where we are. So here is our site with this highlighted in yellow. I click again, access the data. Once again, I want to look at a time series of our observations. We have current. Note that I would like to look specifically at water temperature. So that is the variable that I'm looking for. So I just have to make sure that I click that. I'm going to change our time span for this again to match the time span of the data records that we collected for flax. So here I will put in 06, 25, 2023, 207, 13, 2023. And then I will change that time span to allow first for the visual investigation of the data here on the site. Notice the increasing trend of temperature here and then decrease. So here is a great way to first have your, when you're thinking about these questions, it's great to have students formulate their hypotheses, and it might have started with the article on the hottest day of the year. So that being July 3rd, 2023. Once we do have this data, what we do is we come right down to our numbers here, remembering them again, going back up to, we want a legacy real-time page, just as we did for the flax pond data. And what I will do here is I will change these dates to the dates of interest, and down here as well, I will be changing those. And if you recall, I am only interested in water temperature. If you are interested in gauge height or any of the other variables that would be, perhaps something looking at amount of waterfall or rainfall, you might want to look specifically at some of those other variables. But for here, I'm going to hit go. And again, just as you see here, I have my data set for Iowa, just as I have my data set that I downloaded for Flax. So you have your Flax data now, and you have your Iowa data now. Well, what do you do with it? So once you've obtained the data sets for both the sites that you are interested in doing the analysis on, you then have to take the data and put it into a text edit file. And from that text edit file, we will rework it a little bit into our Excel and our JMP software for data analysis. For this, we're again doing just 2 sites. So I'm selecting the data that I'm interested in here. And notice that I just selected the data. I did not take any of the identifying information at the top. I do know that this is our Iowa site. So the Iowa site data will be first in line. So Control V. Once I do that, I'm going to go over to our data set for Flax Pond, and I will do the same thing. For that. Notice when you're looking at these sites, your site identification number is there, so that when you are recoding your data, you can use this column here as your site identifier. So I will do the same thing. I do not need all of the other information, and here I don't actually need all of that, so I'm just going to take simply the information from below the column identifiers and copy all of the information below. Now remember, this is a larger data set. You can have your students work a smaller data set. So once I've done that, I'm going to paste it into our file. Again, here is our site identifying number for the Flax Pond data set. What I will do now is I will save this as Flax, or we could do Iowa, New York data, and then I do it by the usually the dates. So let's do 6 from our start date 6/25 to 7/13/23, and I'm saving that. I'm going to save it on our desktop just to make that easy for us. Okay, now that this data is set on our desktop, we can go to Excel or Sheets and open up a blank workbook. From here, you will go File, Import, importing your data file, which was a text file that we have. We import that text file and we hit Get Data. It is delimited by the column, so we hit Next, we hit Next again, and we hit Finish. Now we have all of our site data and our parameters within one file. I'm just going to clean this up a little bit. You can delete your cells, or you could work from here. Now, you can change again you could use your site number IDs and or you can type in a name and add a column. I'll show you what I do um, in Jump, and Pam can show you what she does with this file in Excel. So I'm going to save this as all data. So New York, Iowa, all data, and I will save that for further analysis. We will be using that file for Jump. Once the file is put into Jump, we can now just make sure our columns are coded properly. Any type of data that is collected should be coded as numeric continuous, but this is a character trait because we're naming it by day. So we are making this character ordinal, and temperature will be numeric continuous. Our site ID here is simply the name of the site that we collected the data point at. So what we'll do here is first an investigation of our data by summary. So table summary, we can look specifically at the means and standard errors by site. So we can group by site, look at the temperature mean and the temperature standard error by site. So simply by doing that, we could already start to think about the differences within the temperatures. So the temperatures here are 26.34 degrees Celsius and 23.03 degrees Celsius for our Flax Pond site. Starting to think about what are the differences, why are we seeing this? So from here, what we can do is a graphical output. We could, going back to our main file, take our graph builder, drag our site to the axes, and we are looking specifically at temperature. A bar graph would be the most suitable way to represent this data with an error, and an error bar. When we look specifically at the error bar, would be standard error, and that would be a really, really, really nice tight error bar. So specifically, you want to make sure that your error bar isn't rather large. So these can be saved as an output file. You can save them as a PowerPoint. So you can export these as a PowerPoint file. This will allow for your students to put them into a paper or a PowerPoint presentation. So this is Iowa, New York. What we'll do is we'll save that, export it. Again, that could be put into an Excel file. You can also export your tables that you made, so the summary tables that we made, but more importantly, you want to run your statistical tests. So for this, it is a t-test. You're comparing two groups. So what we'll do for this is we'll do an analyze fit y by x. We're going to analyze on our x-axis is our site, and our y-axis is our temperature. We're going to run, for the purposes of this, just a basic one-way analysis, which is a t-test. We're going to drag this down and do that t-test by comparing the means of both sites. Now, the sample size is not equal, so one thing we want to consider in this is that we do want to really run a non-parametric t-test. I will show you that in a second. But after we run that t-test and we see that the p-value is less than 0.05, meaning that there is a significant differences between the means of these groups, we can run what we call a post hoc Tukey test to compare the means. And by doing that, we wind up looking specifically to see how different are these means. And this post hoc Tukey test does that and allows us to see how different they are, and that they are significant. Again, our cutoff for significance here is 0.05. This is coming in at less than 0.0001. So showing that if we did this again, we would get the same results. What I'll do here is I'll close this out, or actually leave it open, and I'll do this analyze fit y by x for non-parametric data. So for data that does not fit the normal distribution and or your sample size is off, what we can do here is put our site again on the x-axis, and there will be a couple of different steps here. So for the non-parametric data, we come here to non-parametric. Because we're comparing the two groups, we're going to do, we could do the non-parametric multiple comparison. So we'll coxin each pair, we'll combine each, and then seeing that here again, we're still looking in significance with a z-score. And then what we'll do here is we'll compare our means again using a Tukey HSD, and that Tukey test again comes in for us as significant. So these reports I like to have students save as both a PDF, so we can export these files as both a PDF, and that way they could put them in their research logbooks. So this is the Iowa, New York data, and that could be saved as a PDF file. And then the other way of doing that too would be to save it as a PowerPoint. So each of these files you're saving as a PowerPoint file, so that you can have your students build a repertoire of their data and then share that data on presentations for competitions. So we can either take the information from the PDF or save it as a PowerPoint. So when we save it as a PowerPoint, we wind up with Iowa data, New York data, PowerPoint. I like to just load it, and here we go for an export of that, and this can be then copied and pasted into a presentation. Okay, now that we have all of our data organized within our JUMP file by site, and then we have our column for temperature, and that we've coded date as well, and in this way we've coded date as ordinal. So let's just see how we've coded the date. So character ordinal. We can go ahead and just make another graphical analysis. We can take our graph builder. We can drag and drop the date onto the x-axis, temperature onto the y. And then because we want to have both sites, what we can do is overlay site over here. Let it think for a minute. So we want to overlay that site. And once we have both those data points, we can then go ahead and show our graphical outputs. So here, one other thing that we could do is we could look at our error interval for each of those dates if we wanted to by looking specifically at the standard error. But because our data is so tightly clumped and we have multiple points for the day, I didn't break down in our table another column by day. So we could code for day if we wanted to look specifically at the day differences. So for now, there are two ways of looking at your data, both again the bar graph representation, of which we have here, and we have um, our file here showing our line graph representation. We have our river site in Iowa and our Flax Pond site um, in Oldfield. And now we can actually start to ask questions. So why do we see this variation here? Why is there such more extremes here and not so much in the river system? Okay, so that's that for now.